Greetings, friends. We are going to look at Science Paper 1, 2020. And in this lesson, we are going to look at Section B. We are going to answer question B1 on Section B. So the first question there says, Figure B1 below shows a simple pendulum suspended from a fixed point. So there is the diagram. The bulb is slightly pulled to position A and then released. The first question is, state one factor that does not affect the period of the pendulum. Okay, so period of a pendulum is affected by a number of things. Period of a pendulum, by definition, is the time taken for one complete oscillation. So the period of a pendulum is mostly affected by the length of the string. However, the period of the pendulum is not affected by the mass of the bulb, and that is our answer. The period of a pendulum does not depend on the mass of the bulb, but only on the length of the string. So the answer for our first question is the mass of the bulb. The mass of the bulb. Okay. Question B says, if the values of time for 20 oscillations obtained were 16.1 seconds, 15.9 seconds, 16.0 seconds, 16.2, and 15.8 seconds, calculate the period of the pendulum. So the period of the pendulum basically can be given by two formulas, or can be calculated using two formulas. That is, period of a pendulum is equals to time over the number of oscillations, or we can use the other formula, period of a pendulum is equals to 1 over frequency. 1 over frequency. So for this question, we are going to use period of a pendulum is equals to time taken over the number of oscillation. The time taken over the number of oscillation. But when you look at this question that we have been given, you discover that the time that you are given, or there are quite a number of, the digits that we are given with the time. So the first thing that I want you to do before you start any calculations, let us find, the average time that you're going to use when calculating the period of the pendulum. So what we are going to do is simply, we are going to add all the figures that we are given there for time, okay? So we add everything, and then we are going to divide by the number, okay? Number of the values that we have, we'll get the average time that way. So I've added everything, 16.1 plus 15.9 plus 16.0, add everything. We divide by how many values are these? There are 1, 2, 3, 4, 5. So we divide by 5. We get the average time, which is 16.0 seconds. After finding the time, we can now use our formula. Period is equals to time taken over the number of oscillations. So the time that we are using is 16. We have just found that average, divided by how many oscillations are we dealing with here. So the question there has made it clear that these values, okay, are of time for 20 oscillations. So on the number of oscillations there, we are using 20. When you do your math, 16 divided by 20, we find our answer, which is 0.8 seconds. Don't forget to put the unit. The unit for period is seconds. So the answer for question B is 0.8 seconds. C says, calculate the frequency of the pendulum. Calculate the frequency of the pendulum. Okay, so frequency of the pendulum is given by two formulas as well. Frequency is equals to 1 over period is the formula I'm going to use. That's the formula you are seeing on the screen. However, we can also use the other formula. Frequency is equals to number of oscillation over time. Okay, so in this formula that we are going to use, frequency is equals to 1 over t. Of course, the 1 is a constant value, it's always there. Here, we just need to substitute the period. So we have just calculated the period. The period is 0.8. So we are dividing 1 divided by 0.8. And when you do the math, it gives you the answer, which is 1.25. 1.25. So that is the frequency that we are looking for. Once again, be careful. Don't forget the units. Frequency is measured in hertz. So our answer is 1.25. Put the unit there, capital letter H, Z, which is hertz, So the period, or the pendulum rather, consists of a mass and a bulb suspended from a fixed support on a string so that it swings back and forth in a regular periodic way under the influence of gravity. That is what this instrument is all about. The period of a pendulum is the time that it takes to complete one whole oscillation or one cycle. So basically, a pendulum is this instrument that is used to measure time. And the period of a pendulum, like we have just read there, is the time taken for one complete swing, also known as an oscillation. The number of oscillations per unit time or per second is called the frequency, which is what we also calculated there, and it is measured in hertz. The period is measured in seconds. And the last point there is the maximum distance, okay? The maximum distance that the bulb swings from its central equilibrium position is called the amplitude. That is called the amplitude. Thank you so much. I'll meet you in the next part as we look at question 2 and the rest of the questions.